Hello there. I'm Charlie. Welcome back to another part of Algorithm Garden. So today we're going to focus in on that challenge we were discussing last time you were here. So last time we talked about how to build this object, and we really want to look a little bit closer at what exactly that sort of means for us. In class we talked a lot about like the significance of making this index and why it's important, and we thought a lot about what Google's doing really, and how anytime you look up any word, it's connecting all of these documents that have already been parsed and put in an index. So we want to go into that process of making an index, and we can discuss a little bit more about why the index matters. So I'm going to go ahead and light our candle, and then we can get started. Whoop. All right, why don't you go ahead and come on over and we can start writing it out on the whiteboard. All right, so let's consider what exactly taking it from the object really looks like. So we have this object, and I'll go ahead and write it over here. Let's just say I have like cat, and let's say cat has 34 and 36 as its IDs, and then we have dog right after it. So dog is gonna have, let's say, just 36. So now let me go ahead and close that. So that's gonna be a lot smaller than the actual object you have, but you get the general idea from that. So indexing involves taking this from this JavaScript object into just a string of values that we can work off of. So here we have our keys, cat and dog, and then we have the values of an array. So what we want to do is we want to take this and we want to just put it into a file. Now let's consider the last time we did something like this. When we were working with our anagrams, we always were taking all of these sorted values and we were putting them into a file. And what the file gave us was a really fast way of accessing all of the terms without having to remake the entire algorithm. We didn't have to resort all of the words. And so we want to do the same thing here, where we don't have to look through hundreds and hundreds of words again and again. Instead, we can just have them all in our object notation. So now let's try thinking about what this could look like. Now in class, we actually looked at a index of a real book, and so oftentimes you would have like something like let's just say this was the example in class, but we had bibliography. Now it doesn't really, the word doesn't really matter, but after the word there was a bunch of page numbers. So the page numbers would just be like 100, 120, and say 130. And so we want to take that same concept that we used for a book, and we want to use that for putting our object into a index file. So really all we would have to do is we have to go one object at a time, or one key value pair at a time. And so we could just do, say, cat, and then we could even use very similar notation that we have for the object, right? So we could just do cat colon, and then we could just say 34, comma, 36. And then we don't just want dog right after. We probably should put it on a different line. Just like a book index, we want each thing to be relatively readable and actually make sense, right? So at the end of this line, we want to say sort of like new line, and then we want to put our second term. So dog, and dog is going to connect to 36. And so then you can imagine how this might look with hundreds and hundreds of terms, right? Each one will be able to connect to 2 or 3 or 4 different documents, and we'll be able to see it very easily. And then looking forward, we'll have to consider how to take this and actually turn it back into that, right? It's going to be this back and forth, just like what Google is doing with all of their data. So they have these massive indices, much larger than just cat and dog, and they're doing a very similar process where they're taking this and putting it in a form that users will be able to like more easily access. So now that we have this is really the basis of what the indexing will look like for us. But we might want to take it just a little bit further. So tomorrow in class, we'll have quite a bit of time to work on this. And this is the basic challenge where we want to take our object and just write it into a file. But there was quite a few fantastic ideas that we had in class. So let's look at a couple of those. So one of them was something called stop words. So someone was like, well, what if the word "the" is in every single document? That doesn't help us. We don't really want to search based off of the word "the." So what we have to consider is possibly words that we don't want to add. So if we had our object here, what you could consider is while we're looking through all of our pages, what if when we saw like "the" or "and" or "a," what if we just didn't add them? So that's really going to be up to you to interpret more, but there's a lot of good subjects and articles online about stop words, and you can definitely access like a big dictionary of a lot of stop words that are very common in a lot of different texts or documents. So you can certainly avoid like "the" or "a," which are like very challenging for us to actually search on, because you'll really return almost every single document in our overall corpus. The next thing you could consider building off of is something called stemming. So a stemmer or a Porter stemmer, you can certainly look it up, but a Porter stemmer involves taking words that all have similar meaning and turning them into really the same word. So let's look at runner, running, and let's say just run. So let's think about all of these. They all pertain to running, or to run, sorry. And so we could see that each of those gets down to just run. And so there's quite a few articles online that talk about this rule set, but there's also a lot of libraries that already do this. But the goal here would be able to generalize or make our data a little bit more usable in certain senses. So if someone were to type in running, then we could search for run and actually have access to a lot more different articles that may only be attached to running, but actually really just have to do with run. So running would become run, and you can really see, right? Running, runner, it's all part of this same word, run. The last possible enhancement that we have for you, we do hope that you can possibly consider a couple more items on your own, but the last one we have for you is something that was brought up by another student in our class, which was fantastic, and that was term frequency. So term frequency has a lot to do with what exactly is going on inside of a document. So when we look at, say, document 34, we see that in our small index here, we only have the document 34, and that only connects to cat. But what if that document, say, said cat like 6 times maybe? Then we might want some way of defining 34 to have a little bit more to do with like the connection here, right? So maybe we want to actually count how many times cat occurs, because let's again look a little bit more broadly. Let's look at 36 real quick. So if we look at the fact that the document ID 36 occurs in both cat and dog, well, yes, it goes to cat and dog, but maybe we want to sort of have a stronger weighting towards the one that occurs more in that document. So let's say I'll go with cat again. Let's say cat occurred, say, 6 times in document 36, while dog only occurred once, maybe. Maybe we want to consider how exactly we compare these two, right? If we're to look up cat, the document 36 should weigh very strongly in favor of cat, while when we're looking at dog, it only occurred once, so maybe it's not super important. Now, you'll have to consider how possibly we keep track of this. But of course, as we're going, this will appear more in the object building phase, where we're trying to actually add these IDs. And so instead of just adding the ID 36 once, maybe we have to consider how many times cat occurred in 36. So you'll need some counter there. And if we look a little bit more closely in that, right, I'm going to erase our stemming work here. So let's say we had like the cat ate dog. My head's in the way. The cat ate dog, and like cat happy per se. That's a bad example. Now, when we're going through looking at each of these words, right, we need to see that cat occurs more than once, right? So we see cat once, we go ahead and add our document ID up here. So we said, okay, 36, let's go ahead and add it. And then we keep going, we see dog, okay, let's add dog there. And then we see cat again. So then what we would have to do is we'd have to go in here, and instead of just storing 36 in the array, maybe we would store, say, 36 and the amount of times we've seen that word. So you could consider having a 2D array where we have, say, 34, and cat occurred once in document 34, and then we have 36 here where cat occurred twice. So that could, of course, be a consideration. And what this really adds for us is a lot of pizzazz to our search engine. Because all of a sudden, even though 34 and 36 both have the word cat, we would assume that the document 36 may have a little bit more to do with cats. I almost forgot to blow out the candle. Of course, the algorithm garden tradition, so I'll just go ahead and briefly blow it out, and then we'll see you all next time.